burst of light that we call a solar flare. And people actually did see those in ancient times in the white light, even though here we get it from space.
Really?
In the extreme ultraviolet. Yeah, it's happened.
That's amazing.
Yeah, it's really happened. So we're about 3 minutes, 2 minutes before totality now.
Can
So
I sneak back in here with you?
Yeah.
Let's get cozy because I want a front row seat.
Yeah.
So the sun is just the thumbnail right now. We still have just a couple more minutes, but I am amazed at how different it already looks. It looks a lot richer, but I'm still not seeing those kind of prominences or those white lines hidden out. Why am I not seeing those yet?
Well, it is a quiet sun right now, so this is a solar minimum. So you won't see as many. We saw, for those of you who were noticing earlier today, or you want to rewind your broadcast, earlier today when the moon was making first contact, we saw an incredible prominence on the opposite side.
Yeah.
One thing I will say, down in Chile right now, when the sun is this narrow slit, the world around you looks very peculiar. It's not only dark, but everything is in super sharp focus because this thin line of light produces sharp shadows everywhere.
It's like a pin spot heading across the earth.
It's exactly like.
Can we go to the Chile cam and see if we notice any differences there? That wide shot that we have on the top of the mountain. Okay, I feel like I'm noticing a difference. I do see sharper shadows on the ground. It looks cooler to me. And we are lucky enough that we actually have a phone line out there on the mountaintop.
All right.
Executive producer Robin Higdon is on the line with us, ready to share what she's experiencing out there at the observatory. Robin, what does it feel like out there?
It is amazing here. Everyone is getting so excited. We're standing on the top of a very tall mountain. We're at 7,200 feet with a couple hundred scientists from around the world. It's gotten very dark. Just in about the last 5 minutes, the temperature's really dropped. We all have to get jackets on. So that just this tiny little sliver, feathers on the ground are sharp and dark and very long. It's incredible.
And how many people are there? You said hundreds. Does that include scientists and other people from the community?
Right, there's about 200 people here.
Look how dark.
Scientists, there's 5 different scientific activities being conducted. They're repeating Einstein's 1919 experiment, amongst other things. There's a lot of photographers here, a lot of press, so TV and PR and many other people.
I can tell we're getting
Excitement in the air.
We're getting
close
really
here. We can see
now.
the image on the screen. We're going to let you lead the conversation since you're there, experience it in person, Robin. But already the image of the wide shot, we can tell how dark it is, how red it is. It looks like sunset, but you still have some time. And I don't know if we have a countdown, but I feel like I can see that moon almost totally eclipsing the sun. And at that...
About 20 seconds.
We are seeing sunset all the way around the edges here. We're getting a 360-degree sort of orange glow on the horizon. People are starting to yell and surf here. Lots of groans of excitement. Oh, and there it goes. It's getting
there we go.
All right. This is the good part.
As long as I can see that little edge, I'm not mixed off my glasses. It feels like we're just moments away. It's totally dark here now.
Wow.
All right.
We've lost image. There it is.
There we are.
The corona is starting to reach out in 2 different directions, on the top and on the bottom. 2 very even, smooth streamers coming out. I can see a little bit of the detail in the streamers now. It's a beautiful, deep coronal glow all the way around the edges. I can now see one of the planets. I don't think you can see it in our telescope image, but I'm seeing planets and stars starting to emerge. And again, the whole horizon is glowing orange and yellow. The streamers are reaching out. It's gotten very still here. I think stop yelling and I'd like to hear it.
There we go. There's a prominence.
We have a nice close-up view of that prominence in the side of the sun there. It must be incredible seeing it from the ground.
If you can see it.
Beautiful.
Yeah.
That's big. That's a big one.
So this is close to what we saw on the models. They took the filter off the telescope so we can get that kind of white light, what our eyes can see without any glasses.
And that's the one we saw earlier when the moon was making first contact and we were saying, oh my gosh, we won't see that again until totality, and here it is.
Robin, can you tell us how this is different from...
one is very dark. It's very, very dark here. The sky is a deep, deep dark blue, and right where the moon is the darkest spot I've ever seen.
That's because of the altitude.
Hakeem, what was that?
No, that's because of the altitude. At 7,200 feet, you don't have the rest of the atmosphere shining light on you, right? The molecules in the atmosphere. So it's almost like you're in space.
You are now closest to... It is absolutely gorgeous on the monitor. I can't imagine what it's like being there in person. I feel like we're seeing a little bit more light coming around.
See the prominence at the bottom?
Yeah, yeah. It's a lot of red glow.
5 o'clock.
I'm seeing some bright pink emerging. I am actually up there.
Oh,
the diamond ring.
Here it comes.
Absolutely beautiful. I have to put my glasses on, unfortunately.
please
Wow.
do.
Beautiful night drink.
That was beautiful.
Bright, white light.
Wow.
Oh, look at
And we are getting a beautiful shot, wide shot of the
Look how dark it
observatory
got.
up there. It looks like it's past sunset there, but in just a few
And there's that
moments,
planet.
the light's going to come back
that
on
it?
the Earth.
Yeah, yeah.
So
I
that-
think, or is that a light?
I can't tell.
It's already lighting up here.
Yeah, we can see that. It's what I'm amazed by is you really get a sense of how quickly the moon appears to move. It does move, and also appears to move based on the rotation of the Earth. That just flew by. You could have fooled me that was much faster than 2 minutes, but that was about 2 minutes and 40 seconds, wasn't
Wow.
Yep.
It was incredible. I can literally see that crescent now growing. Like, just, it's getting bigger and bigger and bigger with every second. The moon is truly moving fast.
it? Well, I am envious of where you are, Robin. Thanks so much for bringing the telescopes and the crew out there
Thank
to
you.
bringing us up live from Chile. We'll talk to you when you get back and hope you travel safely. And the audience here is also going wild. So I gotta say, we've all seen total solar eclipses in person. You've seen more than I have, but even from the one I've seen, this one was markedly different. Can you tell me about your past experiences, Linda?
Well, I've had two. One was in Indonesia, which was my first, and it was very cloudy, extremely cloudy. We were lucky. We did manage to see totality, which was spectacular, but that moment of that skinny bit of light with every single cloud being sharp was amazing. And of course, the 2017 eclipse across America was breathtaking. This one, I think, was interesting for the reasons that Robin said, that being as high as she was, the sky was incredibly dark. And so in both the eclipses I was at, I can't say it was in a super, super, super dark blue.
Yeah, and we're going to get to see an eclipse over South America in 2020, right, Hakeem?
Yep, that's right. And next summer, that's the case, right?
Just next summer, yes.
Yes, yes, yes. So I've seen four in 2006 from Ghana, 2010 from the South Pacific and Mangaya, 2012 from Australia, and then 2017. And the local climate matters, the altitude matters, but also what's really cool and interesting is the animals in that location. So the very first one I saw in Ghana, when it got dark, the nocturnal animals came out, and that was just made everybody go crazy.
That sounds incredible. So next year's a total solar eclipse in South America, and don't forget, in 2024, the total solar eclipse comes back to North America.
That's
It's
right.
going to be sweeping up through the Northeast. So we know when eclipses are going to happen. Thanks so much,
Yes.
Hakeem and Linda.
You're very welcome.
How do we know when the next solar eclipse is going to happen? Well, a lot of observation has to go into that. So Exploratorium educator Paul Danstep is here to tell us a little bit about some of the ways that we can predict these cycles of total solar eclipses. Thanks, Paul.
Sam doesn't have an earpiece?
Hi there. So, having seen totality, now we can ask ourselves, how did we know this was going to happen? So human beings have been predicting eclipse events for thousands of years, since before we knew the Earth was orbiting the sun, since before we knew that the moon moved in an ellipse, since before we knew any of the fancy stuff we know now. So I want to show you a way of predicting eclipses that can be done just using ground-based observations of how the moon moves in the sky. So I have an image here of the sky right before a solar eclipse, and if we look at this, we can see...
Is the remote on? There we go.
Yeah. So this is during a total eclipse, and when one of these is happening, we can ask ourselves, when will this happen again? So immediately after an eclipse, we have two things in the sky to think about. We have, first of all, the sun, and then the moon, which is right next to the sun. It just drifted past it. And over the course of the next day, the moon's going to keep drifting, and it's going to get about this far away from the sun. So given that drift speed, we can predict that it should take about 29 and a half days for the moon to make a full lap around the sky and meet up with the sun again. So let's follow the moon day by day as it goes through its monthly cycle. We can see it hit each of its 4 phases, and after about 29 and a half days, it's going to be back in the vicinity of the sun. But we're not going to see an eclipse because, as Eric Muller explained earlier in the program, the moon has some extra motion to it. From the surface of Earth, what we see is, in addition to the sideways travel of the moon also seems to be going through a kind of subtle up and down motion. So in order to cause an eclipse, the moon needs to be vertically aligned with the sun, and it crosses this line once every 13.6 days, completing a full up and down cycle after 27.2 days. So let's start with an eclipse and now follow the full motion of the moon as it makes its way around the sky. It completes its up and down cycle after 27.2 days. It catches up with the sun after 29 and a half days, but it's now 2 days into its next up and down cycle, causing it to miss. If we follow it for another lap around the sky, we see that things get even worse. It completes its second up and down cycle after 54.4 days, but doesn't reach the sun till another 5 days after that, missing by an even wider margin. So if we keep our attention on the sun, we'll see the moon fly by every 29.5 days, and there's some near misses, but a total eclipse won't happen again until the up and down cycle matches up with the around the sky cycle. They do eventually come back into sync after 6,585.3 days, or 18 years, 11 days, and 8 hours. If we look down on the Earth during an eclipse, like this one, which happened in America in 2017, we see the shadow of the moon cut across the Earth's surface. And anyone standing in the path of that shadow will witness an eclipse and will be able to predict that there should be another one in 18 years, 11 days, and 8 hours. So let's fast forward 18 years and 11 days. Now, this next eclipse won't start for another 8 hours, and during that time, the Earth continues to rotate. So when the moon's shadow does cut across the Earth's surface, it's going to do so in a different location, this time cutting across China and heading out into the South Pacific. 18 years after that, a nearly identical eclipse will cross North Africa into Southeast Asia. So this repeating family of eclipses is known as a Saros cycle. So these are all eclipses from Saros number 145. Every eclipse belongs to some Saros, and there are currently 40 active Saros cycles, each spitting out eclipses on a repeating 18-year schedule. So if you look at a map of eclipse paths, like this one showing all of the eclipse paths from 2001 to 2025, you can often spot pairs of eclipses that belong to the same Saros. For example, these two paths look really similar, and they're about a third of the way around the Earth from each other. And if we look at their dates, we can see that this one happened in 2003, and this one will happen 18 years later in 2021. This is a pair of sequential eclipses from Saros number 152. So 18 years ago, this eclipse happened in South Africa, and the eclipse we saw today is the next the next eclipse in Saros number 127. So getting back to our original question, when will this happen again? We can predict that there's going to be an eclipse 18 years from now in 2037 crossing Australia. So those are the basics of this ancient method of eclipse prediction.
Thank you so much, Paul.
Sure.
That's so interesting. So the eclipse we just experienced is kind of like a sibling or a cousin of what we saw in Zambia in 2001.
Yeah, we've covered every kind of eclipse currently available, and now we're just running through the catalog again.
And they're almost the same, so you might call it a syzygy similarity.
You might call it a syzygy similarity.
I will. Thanks, Paul.
All right, take care.
So you can already see back on the telescope live from Chile how much of the sun has already reappeared. The moon is continuing its path. And we often talk about the moon as the instigator of the eclipse, but we can't forget the star of the show, which is the sun. And there's so much more that we have to learn about the sun. So we're joined now by NASA senior educator Eric Christian to talk with Hakeem about some current solar research.
Eric, you're the star of the show, man. Forget what you said. All right, so tell us about what you're doing with the Parker Solar Probe.
So last year, NASA launched Parker Solar Probe. It was an amazing night launch of a big rocket, the Delta IV Heavy. You can see here on the screen. And this is our first mission to the sun. We're actually going to go to within 4 million miles of the surface of the sun. Go to where the action is for the first time.
Wow.
And measure some important things about the sun that we've been wondering about for 50 years since NASA started.
Yeah, you can wonder about it and observe it from a distance, but there's nothing like being there. But really, it can get really hot close to the sun. So how do you deal with that?
So that's one of the reasons why it's taken us more than 50 years to get this mission done. We've needed the technology to catch up to where we could actually do this. There's an enormous heat shield on the front of Parker Solar Probe. You can see it here, the big white octagon. That protects us from the sun. My instrument and most of the spacecraft hides in the shadows behind that heat shield. And it's because of that heat shield that it's new developments. It's carbon foam, carbon fiber. It's only now that we can do this amazing mission, our first mission to a star.
So it takes sunscreen to the next level.
Oh yeah, it's SPF millions.
There you go. What are we looking at right here now?
So, as one of the problems with this mission is that when we're doing the most interesting science, when we're close to the sun, we can't communicate with it because the sun is a source of radio noise, and so it's like trying to talk to someone who's standing next to a loud band.
Signal to noise ratio.
Right, exactly. So even when it's close, Parker Solar Probe sends out a single tone, a single note that lets us know it's okay. And every day or two, we can get there. This is one of our first images. We've actually got a camera on Parker Solar Probe called Whisper. It's two cameras aligned with each other, and they look off to the side, because if they looked at the sun directly, it would get completely fried. And so this is looking at the streamers that you see during the
what's that bright
eclipse.
dot there?
So that's probably a star, and there's some artifacts to it, but it's really the streamers that we're flying through.
Wow.
Parker Solar Probe will take pictures of the corona as we fly through
It's like you can taste the sun.
Yeah, it's going to be great.
Delicious. A little spicy though.
Yep. And so my instrument measures particles from the sun. We've got another one that measures the solar wind. We've got instruments that measure the electric and magnetic fields.
All right.
This is really exciting. We're starting to get data. We launched last year.
Wonderful.
We're starting to get data. We still don't understand the data. We're working on our first scientific papers, but this is going to be
for
over
next
the next
year's
6 years.
eclipse. You can give us an update. Last time we did this, you hadn't flown yet. Now you're up there. So let's see what the sun looks like right now. What is going on there?
So
Thanks, Eric.
Thank you, Eric. Thank you, Hakeem. We are getting closer to the end of our broadcast, but I want to say there's still lots of exciting science being done. We talked a lot about what we saw, the prominences coming out of the edges of the sun that we could see sometimes during eclipses, and we heard that those are caused by magnetic fields. But the sun isn't the only celestial body with magnetic field. So here to talk with me more, we have Troy Klein, also with NASA, he'll give you his official title, who's been working on some missions that help us explore the Earth's magnetic fields. Hi, Troy.
Oh, it's a pleasure to be here with everybody. Actually, I'm Troy Klein. I come from Goddard Space Flight Center, and the job I do there, I have two jobs. One is the director of the STEM Innovation Lab, which is a wonderful space where we create maker activities, much like they do here at the Tinker Space here at Exploratorium. But my other job that I had before that was working with a magnetospheric multi-scale mission, the MMS mission, and that's a very interesting mission, which is why I'm here today.
Great. I think we have a video. We'll get that going now to kind of see what involved. And so this launched in 2015, yeah?
That's correct. And what people tend to forget is the sun and the earth are both gigantic magnets. And as a result, they have enormous magnetic fields that often collide and interact with each other. This mission was launched in 2015, 4 identical satellites, exactly like the one you're looking at right now. And they were launched on top of an Atlas V rocket. They're currently in orbit around the Earth, flying in a tetrahedral pattern that we'll see in just a little bit. Now, what they're looking for is where the magnetic field lines, often of the sun and or the Earth, come together and collide, and often the Earth's own magnetic fields, because of all the activity in space, collide and produce that enormous invisible explosion that you see right there.
So in this animation, those lines are highlighted red and blue, but it's not actually visible to our eyes.
That's correct, which is why there are 25 different instruments aboard each one of those satellites. And here is another example of the magnetic explosion. Now, when that happens, enormous amounts of energy are released into the north and south poles, which create the aurora borealis and Australis. And here you see the formation pattern. Now, one of the really interesting thing is we have 4 satellites because we want to capture that data in 3 dimensions. And in order to do that, you have to have 4 points of view. So if you had a soda can in the front of your table in front of you, and you wanted to capture the top, the bottom, the sides, and all of it, you would have to have 4 different points of view to capture it in 3D. That's what MMS has done successfully multiple times, and this mission is actually changing the way we understand magnetism. And it's this magnetic structuring that we see around the sun that creates the shape of the corona and of coronal mass ejections and so on.
So this has been collecting data since 2015. It's still coming in, and we're still learning lots from this mission.
That is absolutely correct. It's so successful, and congratulations to everybody out there that's on the MMS team right now.
But it's not just for NASA and just for hardcore research scientists. This data can be available, right?
Thank you for asking that, because what we do is, part of my job is taking the massive amount of information that we get from our scientists and engineers and try to turn those that data into something that's usable by us in the public. And many of you may have heard about the Maker movement, which is really sweeping the nation and the world. NASA is listening to that as well, and we've decided to create maker spaces, and one of them is at Goddard Space Flight Center right now. And in that maker space, we have virtual reality, we have 3D printing, coding and electronics, and you name it. And we're recreating some of those data sets in virtual reality, so you can actually fly through real data sets of the magnetic field.
Wow, that sounds incredible. But just being honest, would you rather experience the magnetic fields around the total solar eclipse in virtual reality or in real life?
Hands down, virtual reality. No, I'm just kidding. No, absolutely. I've been in, this counts, so this will be my 4th eclipse to experience with, and 2 of which was with the Exploratorium.
Yes, and we're happy to have you as a partner. Thanks so much, Troy. We'll see you next time. That being said, we now have more chances to view total solar eclipses from the path of totality. As mentioned earlier in the broadcast, the next total solar eclipse is also going across South America. You can see in this map that we're going to put up that it is a little bit more south than the one that we saw today, but also going through Chile and Argentina. What's most exciting is in 2024, you see the path totality crossing back up through Mexico and up through the northeast of the United States. So North America will get another spectacular total solar eclipse, and we invite everyone to come and check it out. It's one of our favorite phenomenon. And though we're beginning to wrap up this particular broadcast, this is just the beginning of some of the fun we're having at the Exploratorium. July marks Moon Month. So all month long we're celebrating all things lunar. You can see there in the middle of our museum we have this giant topographically accurate sculpture of the moon. It kind of looks unbelievable, but it's there, it'll be with us. And around it we're doing programs, performances, lectures, culminating on July 20th, where we're taking a full day to celebrate the 50th anniversary of the Apollo 11 landing on the moon, which is an auspicious anniversary because as of now, NASA is working on its next lunar mission, the Artemis mission, which intends to put both men and women on the moon and let's give it up for that, and teach us so much more about what it means to live out in space and possibly act as a potential launch pad for people and astronauts and instruments to be living on Mars. So keep an eye out for that. Before we end, though, I want to give one more big thank you to all the crew and talent both here and in Chile, especially the staff of CTIO who helped make this all happen for this particular broadcast. I look forward to seeing you all underneath the shadow of the moon. So from Pier 15 in San Francisco, I say adios and stay curious.
From the furthest reaches of our solar system, to the storms of Jupiter, to asteroid sample collection, NASA's New Frontiers program was created to tackle specific questions about our solar system, deemed top priorities by the planetary community. The first of these missions, New Horizons, launched in 2006, still provides groundbreaking scientific data today. New Horizons was humanity's first encounter with Pluto and its moons, uncovering that this dwarf planet is a dynamic world unlike anything ever imagined. But New Horizons didn't stop there. In 2019, this intrepid spacecraft visited the most distant object ever explored by humankind, named 2014 MU69, beginning the exploration of the mysterious Kuiper Belt, a region of primordial objects that holds keys to understanding the origins of our solar system. The second mission, Juno, has been unlocking Jupiter's secrets and sending us breathtaking images since 2016. By studying the planet's atmosphere, interior, and magnetic fields, Juno continues to improve our understanding of the solar system's beginnings, revealing the origin and evolution of Jupiter. Next up was OSIRIS-REx, a mission that arrived at near-Earth asteroid Bennu in 2018. OSIRIS-REx will directly sample an asteroid and return the sample back to Earth in 2023. The team will use state-of-the-art labs on Earth to analyze the sample, which will help scientists understand the possible building blocks of life, as well as improve our understanding of asteroids that could impact Earth. And today, we announce our next mission to explore our solar system.
NASA is pushing the boundaries of human knowledge and expanding the limits of technology. Today, I am proud to announce that our next New Frontiers mission, Dragonfly, will explore Saturn's largest moon, Titan. Dragonfly will be the first drone lander with the capability to fly over 100 miles through Titan's thick atmosphere. Titan is unlike any other place in our solar system and the most comparable to early Earth. The instruments on board will help us investigate organic chemistry, evaluate habitability, and search for chemical signatures of past or even present life. This revolutionary mission would have been unthinkable just a few short years ago. A great nation does great things. We will launch Dragonfly to explore the frontiers of human knowledge for the benefit of all humanity.
Hello. Welcome to NASA Science Live, your opportunity to go behind the scenes at your nation's space program. I'm Greg Hautaloma, and I'm your host for today's special edition. We've all just heard the great news that Dragonfly has been selected to visit Saturn's moon Titan, the next mission in our New Frontiers program. Now let's get a little context about that from our head of the Science Mission Directorate, Thomas Serbuchen, and Dr. Lori Glaze, head of our Planetary Science Division.
Hey, I'm Thomas Serbuchen, Associate Administrator for Science.
And I'm Lori Glaze. I'm the Director of Planetary Science Division at NASA.
And we're so excited to have selected Dragonfly to go forward as the next New Frontiers mission. It's the science that really motivates us to do this exciting and difficult mission, a mission that has elements of advanced instrumentation, but also has the ability of flying in that atmosphere of Titan, a world that we, of course, looked at with Cassini and Huygens, our international analysis with ESA and the Italian Space Agency.
And what really excites me about this mission is the fact that Titan has all of the key ingredients needed for life. Liquid water and liquid methane. We have the complex organic molecules, carbon-based molecules, and we have the energy that we know is required for life. And so we have on Titan opportunity to observe the processes that were present on early Earth when life began to form, and possibly even conditions that may be able to harbor life today. We may be able to look for biosignatures there today. So what an exciting mission.
And of course, that mission is led by Principal Investigator Dr. Elizabeth Turtle at Johns Hopkins University Applied Physics Lab, but also by a core team that really brought together a very diverse group, close to 40% female, but also an engineering team that brought just a couple of years ago, brought together the Parker Solar Probe, a very hard technological, challenging mission, brought that together below cost and on schedule. So we're really excited to see what's going to happen here. Go Dragonfly.
Go Dragonfly.
Thanks, Thomas and Lori. They really wanted to be here with us, but they're on another continent right now. But